Hello, Algebra. You need to be watching this video after you've taken the quiz over sections 1, 2, and 4. Okay? I think it's time for me to reveal a secret to you. I hate the exponent rules. I don't like them. Okay? I think that they're really frustrating, they're really confusing, and they're hard to remember. But in order to be able to do exponential functions well, you need to have worked with them before. So that's why we teach you the exponent rules. But the truth is, this is the stuff that I really want you to get. The graphs, the visuals, the representations, because exponents are really valuable information, and they do provide us some really cool insights into some interesting problems. Okay? So, time for a bet. I'm willing to take out all of your homework if, and here's the if, you pay me 1 penny today and you double that amount for the rest of the year. So tomorrow you would have to pay me 2 pennies, and the day after you'd have to pay me 4 pennies, and so on and so forth. Sounds like a pretty sweet deal. I was offered this exact same deal in 5th grade. Okay, and so I went and I thought about it to myself, and I go, you know, it seems like a pretty sweet deal. And my teacher took out a graph and he said this. He says, X is going to be your days, and Y is going to be the amount of pennies that you owe me. Day 1 doesn't seem that bad. I owe you 1 penny. Day 2 still doesn't seem that bad. I only owe you 2 pennies. Day 3, I owe you 4. Day 4, I owe you 8. Day 5, I owe you 16. And day 6, I owe you 32. We've gone through almost an entire week of school, and I still don't owe him more than $1. That seems like a pretty sweet deal to me. And he said, you know what? You keep sitting there. Let's make this keep going up. Okay? So day 7 is 64. Day 8 is 128. Day 9 is 256, meaning we're now at the $2 range. Day 10 is 512. That's $5. Day 11 is 1,000. Man, now math's getting hard. 24. And day 12 is 2,048. And day 13, 4,096. So after 1 week, okay, just under a week, I was at 64 cents. And at the end of 2 weeks, I'm now at 8,192. So after 1 week, I'm at 64 cents. And after 2 weeks, I'm now at $82. And that would keep going on continuously. He showed me by the end of the month, I'd owe him over $1 million. So this bet that seems so innocent early on, 1 penny today and you double that amount for the rest of the year, doesn't seem like a big deal. But once you actually start doing the numbers, you find out that that type of growth is absolutely spectacular. And that growth is what we call exponential. Okay? So here's another problem. A zombie attack. The world is getting taken over by zombies. And the 7th graders last year did this problem. And I gave them this equation. I said that y equals 2x. And I said, we got to figure out what that means. Okay? Well, that means y is going to be equal to the number of zombies. And x is going to represent days. Now, if I put this in a table of values, which is what I want to do, okay, right away, I'll tell you, you always have to start at the 0 value. X equals 0 is now. We're on the 0 day. Well, if I did that, that would be 2 raised to the 0 power, which would be 1. Well, tomorrow would be the 1st day, so I would say 2 to the 1st power, which is 2. And second would be the 2nd day, 2 to the 2nd power, which is 4. 3rd day is 8, and so on and so forth, and it's going to continue. And we already have here a pretty interesting looking exponential graph. So let's actually graph that. Okay, let's insert, let's insert here. Okay, so here's our graph. And if I graphed, I would say that we have 0, 1 is going to be our first ordered pair right here. Second order pair is 1, 2. Third order pair is 2, 4. Fourth order pair is 3, 8. Fifth order pair, or fourth order pair, or fifth order pair, sorry, is up here. And all of a sudden, we've been working with linear functions this entire year, and all of a sudden, our graph starts to do this, and it skyrockets up in the air. That's what exponential graphs look like. They grow very, very quickly over time. The growth starts very slow, and they get very, very big. Or an exponential graph could look like the red here. It could look like this. That the growth or the decrease of population is very quick right away, but then it slows down over time. That'll happen a lot with like population of deer and stuff like that. Okay? So this is an example of what a problem could look like for you. I want you to graph this function, and I want you to do domain and range. Well, we're back to our normal type of graphing, which means we're going to do x and y, but I want positive and negative numbers. Meaning I want -2, -1, 0, 1, and 2, at least. Okay? -2 into this graph gets substituted in for x. So y is going to be equal to 3 times 1/2 with a -2 up on top. Okay? Now I'm immediately going to tell you that you can do this by hand. Okay? And you're going to freak out about that, but you can. If I went up here, I would get 3 times 1 to the -2nd power, and on the bottom I get 2 to the -2nd power. I flip those to give me 3 times 2 squared over 1 squared. 2 squared is 4, 1 squared is 1, so it's 3 times 4, which is 12. Okay? That being said, though, I think that there's a lot of value in being able to plug those numbers into a calculator. So for the second one, I need to substitute this 2 here for a -1. So I always put my fractions in parentheses. 1 divided by 2 raised by a -1. And that gives me the answer of 9. 0 is always very easy, because that means we just plug in a 0, so that means this whole term is going to turn into a 1. So we're left with 3 times 1, which is 3. 1 means that this whole term is just 1/2, so it's 3 times 1/2, which is 3/2, or 1.5. And 2, we plug that in for 2. That, now we're going to use our calculator. We end up getting 0.33 repeating, or 1/3. Okay? Taking a little bit of time here. We got to speed up. So, let's graph this. So pull this down. I would get -2, 12. That's up here. -1, 9's there. 0, 3. 1, 3/2. Right there, and 2, 1/3. And if I made the shape that I had done before, it'll always look like this. Now, there's my graph. If I did 3 here, just out of pure curiosity, it would end up stretching down here like this. But if you're ever working with domain and range, I want you to graph with a calculator. Remember, domain and range are alphabetical, so domain represents the x's, range represents the y's. So let's graph this on our calculator. So we had 3 parentheses 1 divided by 2 raised to the x. Zoom standard. We graph. So there's our graph. If we zoomed out a little bit, it'll look about the same. Okay? Let's go back to standard. Whoops. So, our graph is fairly accurate down here. We have to think about what could the x's be. Well, even though here are x values, it looks like every x value here is covered, and every x value going this way is going to be covered because this line's going to go up, but it's going to continue on both directions. Therefore, our domain is going to be all real numbers. But we got to think about our y's. Our y's are these values up here. It looks like all of these y's are covered along this line here, but this line here is never actually going to reach 0. If we looked at our table here, this number here gets infinitely close to 0, but it will never actually get there. These we will cover in a little bit. So it means these numbers, our y's, are never going to be 0, but they're anything above that. So it's going to be any number greater than 0, meaning we know how to show that. We get out our inequality and we go y is going to be greater than 0, and that's our range. Our domain's all real numbers, and our y is greater than 0. Okay? So we're doing a shipwrecks problem. I want you to pause this one and try to graph this right here with negative and positive values. So let's pause it quick. So we're back. I'm just going to quick graph, -2, -1, 0, 1, and 2. That's our x's. These are our y's. Whoops, I don't know what happened there, but it looks bad. So I'm going to use a calculator to graph. So I'm going to go 180, parentheses 1.2, raised to the, -2. It's 125. And I'll show you a nice little shortcut for the rest of these. If we graphed this, 180, parentheses 1.2, raised to the x, and I went to my table of values, I went back to 0, it'll give me my table of values. So this is 150, this is 180, 216, and 259. So that means as the year goes along, the shipwrecks S, or our Y in this case, are going to go up quite a bit every year. Okay, so that's just another practice on graphing. Last one, I want you to graph 4 raised to the x, and I want you to find the domain and the range. Okay, so we're back. Last one. This one I know we can actually do by hand because it's not a terribly hard graph. Y negative, I did these backwards. -2, -1, 0, 1, and 2. This one, 4 to the -2nd would be 1 over 16. -1 would be 1 over 4. This would be 1, 4, and 16. So the graph, and I'll just graph it by hand, show you what a sketch looks like. -2, 1/16 will be right there. 1/4 will be right there. 0 will be there. 1/4 will be here, and the last one will be way up there. So our graph, our nice little sketch, is going to look like this. And remember, this is never going to reach 0. It's just going to go on infinitely. So our domain will be all real numbers, because domains are the x's, range are the y's, and the range is going to be anything above this line. That line is 0, so it's going to be y is greater than 0, just like we had before. Alrighty, I ran a little long on this one, I apologize, but here are your problems. Let's see, 3, 6, 9, 12, so we need to get 11 to 12 right here. 3, 5, 8, 10. So we need to get 8 right here. Okay, good luck.